Okay, so I want you to try this 7a on your own. So go through it. It's very similar to what we did back in example 7. So hit pause and then come back with me. Okay, so you should have answers for A and B. So now we're looking at different types of pants. So it says if you buy a pair of pants in your regular waist size without trying them on, probability the waist is too tight is 0.3. Probability the waist is too loose is 0.1. Now they want to know if those are mutually exclusive. Yes, those have to be mutually exclusive because you can't have pants that are both too tight and too loose in the waist. So yes, those would be mutually exclusive. So if we want to find that probability, all we have to do is add the two together. Same thing for 7b. I want you to hit pause and then come back with me. Okay, so you should have A and B done. Now, they're giving you numbers in percent form. So when we talk about probabilities, you can talk about percents, but we're going to look at decimals here. So when I talk about these, I'll put them in decimal form first. Now, as we go through this, you have students that need math, need English, and some need both. So that means they're not mutually exclusive because you have some that need both math and English. So for part B then, if I want to find that probability, I look at my probability for those that need math, my probability for those that need English, then we have to subtract the 0.55 because that's those that need work in both areas. So when I get that then, I have a 0.95. Now, if you wouldn't have subtracted the 0.55, you're going to have a number bigger than 1. That should be a clue that something went wrong because you should never have a probability bigger than 1 when you go through these. Okay, now for example 8. This is usually the hardest part of these sections, reading these tables. So when we have this table, the total is 140. So they're going to give you row totals and column totals as you look at all those. So when you're finding probabilities, just remember the whole total is 140 here. Now if I want the probability of D, so the probability of being a Democrat, you've got to find the total number of Democrats, put that over the total number of people. And then make sure you simplify your fractions. All of your fractions should be simplified as you go through these. Now then, our probability of an executive, again, find the total number of executives and put that out of the total number. Now for part B, you want to compute the probability that someone's a Democrat given their first an executive. So what you want on the bottom of your fraction is the total number of executives. Because whatever comes second after the bar has to go on the bottom of your fraction. So there are 48 total executives. So 48 is going on the bottom of your fraction. On top, then, is the number of Democrats who fit in the executive category. There are 5 of those. So 5 out of 48. Again, when you have the bar, whatever letter comes second is going to be your bottom number. So you want the total for that row or column. That goes on your bottom number. The top number is going to be the number from your first group that fit in that second group. So we have 5 that are Democrats in the executive row. Now for C, they want the probability that we have both a Democrat and an executive. So this one we are not going to multiply with because what you're looking at is in your chart we have 140 total people. So the probability of being both a Democrat and an executive is that one number that fits in the Democrat column and the executive row. So if we go back up to our chart here, the one number that fits in the Democrat column and the executive row is 5. So we would have 5 out of 140. Now if we want Democrat or executive, now we're going to be adding some things together. So we have to find the total number of Democrats. There were 68 out of 140. Then we want the total number of executives. So if you look at your table there, total number of executives was 48 out of 140. Now we have to get rid of all the people that fall in both the Democrat category and the executive category. Because if I don't subtract it, you're counting those people twice. So it's not going to give you an accurate probability. So we have to get rid of those that are a Democrat and an executive. There are 5 of those because we just found them in Part C. So we have to subtract 5 out of 140. So we should have 111 out of 140. Now you're going to do the same thing here for number 8, same chart. So as you go through this, go back and look at our example 8 and compare what we did. So really try to do this one on your own so you can see if you're picking up on how to find all these different parts. So hit pause, come back to me. Okay, so you should have answers for A, B, C, and D. So first off here for A, we want to find the probability of an independent. So there are a total number of 17 out of 140 independents. Then we want the probability of being a production worker. There are 92 out of 140, so that's 23 out of 35. Now for part B, remember for this one, what we're going to do is put the total number of production workers on the bottom, and then the number of independents who are production workers are on the top. So my total number of production workers was 92. My total number of independents that are also production workers are going to be 8. So 8 out of 92 is 2 out of 23. Now for part C, you want to find the probability that they're independent and a production worker. Remember, we don't multiply. We're going to put the total on the bottom, and we want the number that falls in both the independent column and the production worker row as our top number, and that is 8. So it's going to be then 2 out of 35. Now our OR. So the OR, we add the fractions together. There were 17 out of 140 independents. There were 92 out of 140 production workers. Then we must get rid of the ones that are both independent and a production worker at the same time. If not, you're counting those twice because they fit into both column and row. So we have to get rid of then 8 out of 140. When I subtract that, I get 101 out of 140. The last page of this section is kind of a summary here of everything we did in 4.1 and 4.2. So it might help you so you can keep going back and looking at those for all your different formulas for these. But these are all of the probability rules from 4.1 and 4.2.